Okay, this section is just going to be some practice problems on finding derivatives with functions that have logs in them, whether they're natural logs or logs with other bases. Bear with me on the pauses. If you're only watching this through Nomia, the pauses might not be that long. AP Calc kids, the pauses are going to be just fine because this is the video that's going to go into Edpuzzle, and then there's going to be some questions to go along with the video, and that's the thing that's going to make the pauses. Okay, in section 3.5 on the chain rule, you got some new formulas. One of them was the derivative of a to the x. So you know the derivative of e to the x is e to the x. The derivative of e to the u is u prime e to the u. You also in the chain rule section got the derivative of a to the x and a to the u. At that time I gave you some formulas early. These four formulas were the ones that I gave you early. So the derivative of the natural log of x was something, and the chain rule version was something very, very similar. You just had to make sure you accounted for the derivative of the inside, or the g prime of x, so to speak. And then the same thing with the log of x with a different base, and if it was not just a single variable. So what I want you to do now, and I'm going to make this an interactive part, is I am going to ask you to fill these in, answer the questions, and then when you are able to advance in the video, then you'll see them, the correct answers written in, and you just compare and make sure they're the same. Okay, hopefully you got these answers right, and if you didn't, here they are. Fix them in your notes. Okay, on this page I would like to do the same thing. You should write down in your notes the properties of logs, where you can break up the natural log of a product of a and b, the natural log of a quotient, or the natural log of a to the b. So again, this video is going to pause pretty soon, and you'll be asked to type those in. And then after that, let's go through, well, then you can check your answers. And then let's remember what the graph of the natural log of x looks like. And then that's going to tell us the domain, the range, and a couple of natural log values that you want to make sure you know that will make life easier. Okay, hopefully your properties were correct. Now let's look at the graph of the natural log of x. Remember that the graph of the natural log of x, or any log graph for that matter, has a vertical asymptote on the y-axis, and then the graph itself is going to look like this. It's a always concave down graph that is always increasing. It increases very, very slowly, so we say it increases at a decreasing rate. That's how you know it's going to be concave down. What is the domain? You could see that the domain does not include 0, but does go to infinity. The range obviously starts out around negative infinity, and not as obviously goes to infinity. There is no horizontal asymptote. It grows very slowly, but it grows. And a couple of values that you want to make sure that you know are the natural log of 1 and the natural log of e. Now again, make sure that you also remember that the natural log of 0 would be undefined. Okay, so for the natural log of 1, just try to remember this point. This point on the graph is the point 1, 0. The other point to remember, so let's say 2, 3, e is about 2.718, and the natural log of e, as I tried to illustrate on the graph, is 1. Okay, now let's look at some examples. Again, keep in mind here that you can always think of two formulas for the chain rule. Some of you, we've already determined, prefer the f prime of g of x and times g prime of x, and some of you prefer breaking everything up into different functions with different variables. Usually, at least 3, sometimes only 2 functions. Finding dy du, du dv, dv dx, and so on, and multiplying them together. So use either method for all of these problems, and I'm just going to do enough of them so that you can tell when is the new rule involved. So in this one, let me say that I'm going to do the breaking it up. If I break it up, I'm going to have y equals cosine. Again, start these without me if you don't think you need me, and then hit play again and see if we have the same things. And then u, of course, must equal that. So your derivatives. This is your new part, right? This derivative is 1 over x. And then we'll leave it for you to finish the problem. Multiply the derivatives and substitute your u, not u prime, right? U back in to here whenever you rewrite it. Okay, the next problem. The thing that I like about number 8 is there are a few different ways, not a few, but at least 2 different ways to do the problem. One of them is to rewrite the function before you start to find its derivative. So this is, again, f of x, not f prime of x. And this is the natural log of x to the, and let's use a rational exponent, 1/5 power. Then you have a property of logs, right? Where you could say, oh, well, that's just 1/5 times the natural log of x. And again, that is still f of x. Well, now your f prime of x is just going to be 1/5 times the derivative of the natural log of x, because this is just a coefficient. You don't need a product rule or anything, and it's very simple. So again, this is where the new part comes in. You go ahead and finish these. Okay, for the next 2 examples, start out with the same rules you normally would, right? This is a quotient rule. So you're going to take the derivative of the first times the second minus derivative of the second times the first all over the second squared. This is a log with a different base. So think about this one now. This is an interesting problem to look at. We want to at least consider the fact that the derivative of log base a of u is u prime over the natural log of a, in this case 10, times u, right? Where this is your u. Now think about if you do the problem using this formula right off the bat. Look at your u. First off, your u, x over x minus 1, is going to be in the denominator of a fraction, and then your u prime is going to be a quotient rule. So pause this if you need to, because you really want to try to get this answer yourself, and then you'll never forget it. What would be a better way, or something else that you can do first before you start to find the derivative so we can avoid that complex fraction and quotient rule? Okay, did you think of it? So I want to rewrite the function because it's a logarithmic function. I can rewrite it using properties. So the log of a quotient is the difference of the logs, right? So now this derivative is going to be really quick and easy. So the derivative of log base 10 of x is 1 over x with a natural log of 10 in front, or behind. X ln 10 is fine. And then this is a u, so I'm going to do the u prime over u with the natural log of 10 here. However, at least the u prime is still, the derivative of that numerator is just a 1. And I have my ln 10, and I have my u. And you could get a common denominator, but quite often you don't even see a common denominator. And that's your answer. Okay, so the video is getting a little long. I'm going to not do as much work for you, but let's just, again, consider how to start these problems. This is the natural log of a square root of a fraction. So you certainly probably don't want to start out with your u prime over u right now, because your u prime, think about how long it's going to take to find a derivative of the square root of a quotient. It's a chain rule with a quotient rule inside, right? So instead, you're going to want to rewrite the function first, where you take out, you're going to use your natural log of a to the b equals b natural log of a, and for that matter, your natural log of a is going to be the natural log of a quotient, so you're going to split that up into the difference of two natural logs. Down here for number 18, you do not be tempted to pull this 2 out as far as rewriting the function. Okay, so in this case we may be stuck with the function as is. Do you want to maybe try this derivative, pause it, well, pause the video, try the derivative, come back and see if you got the same answer. For this one, I'm just going to think about the general power rule, where the derivative of something to the nth power is n times that function to the 1 less power times the derivative of that function. Alright, so maybe I'll just start this again. Y is the 2 times the natural log of this to the 1 less power times the derivative of the natural log of this. Well, the derivative of the natural log of u is u prime over u. So it was really quite simple, right? Again, here's your n times the function to the 1 less power, it's to the first, times the derivative of the function, which is u prime over u. Okay, and then the last thing, just make sure that you can extend your idea, to do a few more things with it. Not only find a derivative, but sometimes use it. So here we have to find equations of the tangent lines to this curve at the points 1, 0, and e 1 over e. What I'd like you to do is completely try this, ideally in the homework section or class notes section of your OneNote notebook if you can access it from home. Try to pull this in, or at least do the work in there somewhere, so create a new page, with this in it. Or if not, go ahead and do it in your regular notebook with your pencil, and I want to look at it sometime, hopefully before Thanksgiving.